Okay, we look at the function y equals r of x equals x minus 3 over x plus 5. Just to review, we want to graph this thing. We find the zeros of the numerator and denominator. Numerator is x minus 3. It's equal to 0 when x equals 3. Denominator is x plus 5, equal to 0 when x equals negative 5. We find the y-intercept, meaning we find the value of the function when x is 0. The value of y when x is 0, that's going to be the y-intercept. If x equals 0, y equals r of 0. 0 minus 3 over 0 plus 5, that's negative 3/5. We put all that together and we get a reasonable picture of the graph. We go through the x-axis when the function is 0, and that occurs when the numerator is 0. Numerator is 0 and the denominator isn't, then the function is going to be 0. Then we find the zeros, the zeros of the denominator. As we approach, when the denominator is 0, the division is undefined, so there's no point at the x minus 5 on the x minus 5 line. There's no point on the graph. As x gets close to negative 5, x plus 5 gets close to 0, which means if you divide this into the numerator, you're going to get a very big number, maybe a big positive number, maybe a big negative number. At x equals negative 5, x minus 3 is negative 8. So if you're close to x minus 5, x minus 3 is going to be close to 8. So you're going to be dividing a tiny number into, I said close to 8, it's negative 8. You're going to be dividing a tiny number into something that's close to negative 8. To the right of x minus 5, x plus 5 is positive. To the left of x minus 5, x plus 5 is negative. So if you divide by a tiny number to the right of negative 5, a little more than negative 5, like maybe negative 4.9, 4.999, you're going to have a tiny denominator that's negative dividing into this number that's close to negative 8. You're going to get, you're going to get a tiny number that's positive if you're to the right of x minus 5. You're going to get a tiny number that's positive that divides into negative 8. You're going to get a big negative result, so your graph is going to be way down there. And the closer you get, the way downer it's going to be. The further down it'll be. So you're going to have a vertical asymptote, and to the right you're going to approach in this direction. To the left, your x plus 5 is negative. You're dividing a tiny negative number into negative 8, you're going to get a big positive number, so you're going to be here. Also, if x is a huge number, if x is a billion minus 3 is pretty close to a billion plus 5. Okay? If somebody gave you $1 billion, you wouldn't quibble over you get a billion minus 3 or a billion plus 5. Okay, that's pocket change. Less than that if you got $1 billion. So your numerator and denominator are both going to be pretty much a billion, which means they're going to be pretty much equal. So this is going to be close to 1. Okay, you divide two things that are pretty much equal, you get something that's pretty much 1. Now, if you divide by a large, if x is a large positive number, this number is going to be a little bigger than this. So y is going to be a little less than 1. It's going to be very close, but it's going to be a little less than 1. So your graph is going to do this. It's going to approach y equals 1 from numbers that are just a little, eventually going to be just a little less than 1. If you divide, if x is a large negative number, then the magnitude of the denominator is less than the magnitude of the numerator, and you're going to get a number that's a little bigger than 1. So you're going to approach through numbers that are a little bigger than 1 for large negative values of x. So there's the graph. Now, I'm going to talk about the inverse of this function. Okay, the inverse of the y equals x minus 3 over x plus 5 function. How do we find the inverse? Now, people had trouble answering this. Okay, it hasn't been that long since you probably tested over this in your pre-calculus class, getting an inverse function. So the question was how to get the equation for an inverse function. Nobody could give me a good answer. Although I think somebody did give me the inverse function, so they apparently knew. But most of the class couldn't answer this. Then I asked, if you have the table for y equals x cubed, how do you get the table for its inverse? Well, we've done this. We did this with the basic functions. That's how we first defined inverse functions, and surprisingly, nobody could tell me that. But the answer is, for the table, you reverse the columns. That gives you the inverse function. For the function, since you understand that you reverse the columns, you're reversing x and y. You're switching x and y when you do that. So, get the equation for the inverse function, you switch x and y, and then you solve for y. Okay, so you get the equation when you switch x and y. Well, here's the equation. Here's what you get when you put x where y was and y where x was. Now we have to solve this equation for y. Okay, again, we had some trouble. What's the first step you do? Okay, well, when you're solving an equation, you have denominators. Everybody should know that you multiply both sides by a common denominator. If you don't know that, it's going to cause you pain. You will have trouble doing the algebra coming up in the chapter I believe you're probably in right now. Okay, so multiply both sides by a common denominator always. Unless a reason pops up where well, that's not a good idea, but that would be very rare. Okay, so multiply both sides by the common denominator, which in this case is just y plus 5. Well, if we multiply both sides by y plus 5, we get y plus 5 times x. And you know what I did? I did y minus 5 here. This led to all kinds of problems. Okay? I wrote a minus. And that's going to change the solution. We're going to keep going with this. Okay, we're going to find that we didn't really get the correct inverse function. Okay, so we should have y plus 5, but I wrote y minus 5. We're going to go on with it because I did. And that was an honest mistake. I wasn't just pretending to make that so I could demonstrate why you check and how you check. Okay, that comes up a little later. Anyhow, we're going to go on with this. That should have been a plus 5, so that's going to mess up everything. But the steps are still going to be dictated in the same way. If it was y plus 5, we'd still do the same steps. Okay, so the next thing we do, we're going to solve for y. Okay, so we've got a y bound up in this parentheses multiplied by x. We don't want that. So we apply the distributive law here, and we get y times x, which is xy, minus 5x. And that's still equal to y minus 3. Then we put all our y's on one side. Okay, well, we've got a y over here. It's going to become a negative y when we subtract it from both sides. So we get xy minus y. And then I went ahead and added the 5x to both sides. Okay, here. And that puts the equation into this form. And in this form, we're going to factor. We're going to factor y out. We get y times quantity x minus 1 equals 5x minus 3. So now we can divide both sides by the x minus 1 and we'll get y. And we get y equals 5x minus 3 over x minus 1. That really should have been the negative of the quantity, or negative 5x minus 3 over x minus 1. And one member of the class talked to me a little bit afterwards, told me his steps, and he got something equivalent to that because he didn't do this boneheaded thing like I did. Okay? But there it is. Now, we want to check. We want to check to see if this really is the inverse, and when we checked, we found that it wasn't. Okay? And there's the culprit. So if we correct that, everything should work.